Stand at the base of the Great Sphinx of Giza on a quiet morning, before the tourist buses arrive, and run your hand along the weathered limestone of the enclosure walls. What you'll feel beneath your fingertips is evidence of something impossible. Deep vertical grooves, undulating wave-like patterns carved into solid rock, channels that cut several feet into the stone, flowing downward like frozen waterfalls. To most visitors, this weathering looks ancient, mysterious. But to a geologist, these patterns tell a very specific story. A story written in the language of stone, water, and time. A story that, if true, doesn't just challenge what we know about ancient Egypt, it obliterates the entire timeline of human civilization. This is the Sphinx water erosion theory, and for over 30 years, it's been one of the most controversial debates in archaeology, geology, and Egyptology combined. Because these erosion patterns, these deep, vertical channels carved into the bedrock, shouldn't exist. Not if the Sphinx was built when mainstream Egyptology claims it was built. Not if human civilization developed the way we've been taught it developed. Not if the story of ancient Egypt that fills every textbook, every museum placard, every documentary is actually true. The geological evidence carved into the Sphinx enclosure suggests something radical. That the monument could be 7,000, 9,000, possibly even 12,000 years old. That would place its construction not in the age of pharaohs and pyramids, but in a time when humans were supposedly living in caves and hunting with stone-tipped spears. So either our understanding of geology is fundamentally wrong, or our understanding of human history is fundamentally incomplete. Let's examine the evidence. Chapter 1. The geologist who asked the wrong question. In 1990, a man named Dr. Robert Schoch arrived in Egypt with a simple mission. Use geological science to definitively date the Sphinx and end the speculation once and for all. Robert Schoch wasn't an Egyptologist. He wasn't an archaeologist. He wasn't someone with a preconceived theory to prove or an academic reputation tied to traditional Egyptian chronology. He was a geologist from Boston University, a scientist who specialized in reading rocks the way others read ancient texts. His expertise was in paleontology and stratigraphy, the study of rock layers and how they change over geological time. Schoch had been invited to Egypt by John Anthony West, an independent researcher who had been studying the work of R.A. Schwaller de Lubitsch, a French mathematician and philosopher who first suggested in the 1950s that the Sphinx showed evidence of water erosion. West believed the Sphinx was far older than traditionally accepted, but he needed geological credentials to make the case scientifically credible. He needed someone who could look at the weathering patterns without the bias of archaeological assumptions. He needed someone who could read the rocks. Schoch agreed to examine the evidence with one condition. He would follow the science wherever it led, even if it contradicted West's theories. He would be objective, empirical, led only by geological evidence. What happened next would define and nearly destroy his career. When Schoch first examined the Sphinx enclosure, he brought no assumptions about when it was built or who built it. He simply observed the weathering patterns with a geologist's trained eye, and immediately he saw something that didn't make sense. The Sphinx sits in a massive rectangular pit carved directly into the limestone bedrock of the Giza Plateau. When the ancient builders carved the Sphinx, they essentially excavated downward into the plateau, removing hundreds of tons of limestone to create both the body of the monument and the walls of the enclosure surrounding it. This means the Sphinx body and the enclosure walls were carved from the same bedrock at the same time and have been exposed to the same environmental conditions throughout history. The weathering on both surfaces should be identical, and it is. Both show the same characteristic erosion patterns: deep vertical fissures, rounded and undulating surfaces, wave-like horizontal channels, and a differential weathering where softer layers have eroded more deeply than harder layers. To Schoch's trained eye, this weathering pattern had one clear cause: precipitation-induced erosion, water erosion. the kind created by heavy, sustained rainfall over thousands of years. But here's the problem. The problem that would spark 3 decades of controversy. Egypt hasn't experienced that kind of rainfall since the end of the last ice age, approximately 10,000 to 12,000 years ago. Chapter 2. Reading the language of stone. To understand why this matters, you need to understand how geologists read weathering patterns. Different erosive forces create different signatures in stone. Wind erosion creates horizontal weathering, abrading surfaces uniformly with blown sand. Chemical weathering creates surface pitting and flaking. Subsurface water seepage creates horizontal dissolution patterns and cavern formation. But precipitation-induced erosion, weathering caused by rainfall running down vertical surfaces, creates something very specific. Vertical channels and grooves, rounded, undulating surfaces where water has flowed over millennia. Differential weathering, where water concentrates in natural weaknesses, and a top-to-bottom progression, where upper surfaces show more advanced weathering. This is exactly what Schoch observed on the Sphinx enclosure walls. The pattern is unmistakable to any geologist. It's the same weathering you see on limestone surfaces in regions with heavy rainfall. The same patterns found in wet climates around the world. The same erosion process that carves slot canyons and shapes cave systems in areas with significant precipitation. But Schoch didn't just observe the Sphinx in isolation. He compared it to other structures on the Giza Plateau. The 3 Great Pyramids, Khufu, Khafra, and Menkaure, are dated by mainstream Egyptology to the 4th dynasty, roughly 2500 BC. The same era when the Sphinx was supposedly carved. These pyramids were built from the same Mokattam Formation limestone as the Sphinx. They sit on the same plateau. They've been exposed to the same climate for the same amount of time. If the Sphinx was built in 2500 BC, its weathering should match the pyramids' weathering. It doesn't. Not even close. The pyramids show typical desert weathering. Horizontal wind abrasion, surface flaking from temperature fluctuations, sand erosion concentrated on lower courses, and minimal vertical channeling. The Old Kingdom tombs carved into the plateau show the same desert weathering patterns. The temples constructed during the 4th dynasty show the same patterns. Everything built in the traditional time frame shows erosion consistent with 4,500 years of desert climate, except the Sphinx. The Sphinx shows weathering consistent with thousands of years of rainfall. Rainfall that didn't exist in Egypt after approximately 10,000 BC. Schoch's initial conclusion, based purely on geological observation, was cautious but clear. The erosion patterns on the Sphinx enclosure suggest construction during a period when the climate of Egypt was fundamentally different, wetter, with regular precipitation. Based on climatological data and geological weathering rates, that would place the original carving of the Sphinx somewhere between 5000 and 9000 BC, possibly earlier. The backlash was immediate and fierce. Chapter 3. The climate that vanished. To understand why Schoch's theory is so controversial, we need to understand the climate history of North Africa. The Sahara Desert is relatively young, geologically speaking. For most of the past 200,000 years, the region experienced alternating humid and arid periods driven by cyclical changes in Earth's orbital patterns, what scientists call Milankovitch cycles. The most recent humid period, called the African Humid Period or the Neolithic subpluvial, lasted from approximately 15,000 BC to 5,000 BC. During this time, the Sahara wasn't a desert. It was a vast grassland savanna with scattered woodlands, dotted with lakes and cut through by rivers. Archaeological evidence shows hippos, crocodiles, and fish populations throughout the region. Cave paintings from this period depict lush landscapes with abundant wildlife. The Nile River carried significantly more water. Seasonal monsoons brought regular rainfall. The landscape of Egypt looked nothing like it does today. This wasn't speculation or theory. It's established climate science, confirmed by multiple independent lines of evidence. Lake sediment cores showing aquatic ecosystems, pollen records indicating grassland vegetation, archaeological remains of water-dependent animals, and ancient river channels visible in satellite imagery. But here's the critical detail. This humid period ended between 5,000 and 6,000 years ago. By 4000 BC, the climate had shifted dramatically. By 3000 BC, the Sahara had transformed into the desert we recognize today. And by 2500 BC, the supposed construction date of the Sphinx, Egypt's climate was essentially identical to the modern environment: dry, arid, desert. The kind of climate where rainfall is rare and brief, where erosion is dominated by wind and sand, where deep vertical water channels simply don't form in exposed limestone. Yet the Sphinx enclosure shows exactly those water erosion patterns. Schoch's argument was straightforward. If the Sphinx shows weathering that requires thousands of years of sustained rainfall, and Egypt hasn't had that rainfall since the end of the African Humid Period around 10,000 years ago, then the Sphinx must have been carved before that climate shift. It must be older, much older. The implications were staggering. Chapter 4: The Civilization That Couldn't Exist. According to mainstream archaeology, human civilization in 10,000 BC looked nothing like the society capable of creating the Sphinx. We were hunter-gatherers, nomadic tribes following animal migrations and seasonal plant resources. We lived in temporary shelters, we had stone tools, fire, and the first experimental attempts at plant cultivation in the Fertile Crescent. The first permanent settlements, places like Jericho, were just beginning to emerge around 9000 BC. These were simple villages with round mud brick houses. Monumental architecture didn't appear until much later. The earliest stone temples, like those at Gobekli Tepe in Turkey, date to around 9600 BC and represent a staggering achievement for their time. But even these were relatively crude compared to the precision of the Sphinx. The Sphinx is something else entirely. It's a monument carved from bedrock, measuring 240 feet long, 66 feet high, and 20 feet wide. It required the quarrying and removal of hundreds of tons of limestone. It demonstrates an understanding of stone's structural properties, quarrying techniques, and sculptural precision. This is the work of an organized society. A civilization with surplus food production, specialized labor, engineering knowledge, and probably some form of administrative structure to coordinate the work. According to everything we know about human development, that kind of civilization didn't exist in 10,000 BC, which is exactly why Schoch's geological evidence was so controversial. If the erosion patterns really do indicate pre-10,000 BC construction, then one of two things must be true. Either our timeline of human civilization is fundamentally wrong, and there was an advanced society in Egypt thousands of years before the first pharaohs, a society that was then lost, possibly wiped out by the catastrophic climate changes at the end of the Ice Age. Or there's some geological process we don't understand that created identical water erosion patterns in a desert climate where such erosion shouldn't be possible. Most geologists who've examined the evidence side with Schoch's interpretation of the weathering. The erosion patterns are consistent with precipitation-induced weathering. Most Egyptologists reject the conclusion entirely. The idea of a pre-dynastic advanced civilization has no supporting archaeological evidence. The debate has raged for over 30 years, and it's remained bitter, personal, and unresolved. Chapter 5: The Egyptian Response. The mainstream Egyptological community's response to Schoch's theory was swift and dismissive. Dr. Zahi Hawass, Egypt's former Minister of Antiquities and perhaps the most famous Egyptologist in the world, has been particularly vocal. He's called the water erosion theory American hallucinations and insisted repeatedly that the Sphinx was built by Pharaoh Khafre during the 4th dynasty, around 2500 BC. But when you examine the evidence connecting the Sphinx to Khafre, it's surprisingly thin. There are no inscriptions on the Sphinx itself identifying its builder. No cartouches, no dedicatory texts, nothing carved into the monument that says, Khafre built this. The association comes from circumstantial evidence. The Sphinx sits near Khafre's pyramid, The facial features supposedly resemble Khafre's face, though this is highly debatable and subjective, and there's a fragmentary inscription known as the inventory stela that mentions both Khafre and the Sphinx. But that inventory stela is dated to the 26th dynasty, around 670 BC, nearly 2,000 years after Khafre's reign. Most Egyptologists consider it unreliable, possibly a later fabrication or a confused historical reference. There's also the Dream Stela, placed between the Sphinx's paws by Pharaoh Thutmose IV around 1400 BC. The inscription describes how Thutmose, as a young prince, fell asleep in the shadow of the Sphinx and dreamed that the monument spoke to him, promising him the throne if he would clear away the sand that had buried it. What's interesting about this text is the language used. The Sphinx is described as being ancient already, buried and forgotten, a relic from a distant past. If the Sphinx had been carved only 1,100 years earlier, would it be described in such terms? The Great Pyramid was roughly the same age at that point, and it wasn't described as mysteriously ancient. It was documented as a known 4th dynasty construction. The linguistic clues suggest the Egyptians of the New Kingdom didn't clearly know who built the Sphinx or when. But lack of clear attribution doesn't prove great age. It just means the historical record is incomplete. Egyptologists have offered several alternative explanations for the erosion patterns Schoch observed. Chapter 6. Alternative Theories and Counterarguments. The most common alternative explanation is groundwater erosion. Some Egyptologists and geologists have argued that the weathering on the Sphinx enclosure could have been caused by subsurface water seeping upward through the limestone, rather than rainfall flowing downward. The Giza Plateau sits above an aquifer, and groundwater levels have fluctuated over millennia. Could rising groundwater have created the erosion patterns Schoch attributed to rainfall? Schoch addressed this directly in his research. Groundwater erosion creates distinct characteristics. It tends to cause horizontal weathering as water seeps along bedding planes. It creates cavern-like dissolution features. It affects buried surfaces more than exposed surfaces, and it produces chemical weathering rather than the physical erosion seen on the Sphinx. More importantly, if groundwater were the cause, we'd expect to see similar erosion on other Old Kingdom structures on the plateau. We don't. The pattern is unique to the Sphinx enclosure and a few associated structures that appear to be contemporary with it. Another argument is that the Nile floodplain came much closer to the Giza Plateau in ancient times, and periodic flooding could have caused the erosion. But again, this doesn't match the geological evidence. Flood erosion creates different patterns, more horizontal, more uniform, with sediment deposition rather than pure erosion. And the Sphinx sits approximately 60 feet above the ancient floodplain level. Water would have had to rise dramatically and remain high for extended periods, something not supported by Nile flood records. Some have suggested that wind-blown sand, given enough time, could create similar vertical channel, but aeolian erosion, wind and sand weathering, creates horizontal grooves and abraded surfaces, not vertical channels. And we can see what wind erosion looks like on the Giza Plateau because every other Old Kingdom structure shows it clearly. The Sphinx erosion is fundamentally different. Perhaps the most sophisticated counterargument comes from geologists who suggest the erosion represents normal desert weathering over 4,500 years, with the vertical channels forming along natural weaknesses in the limestone, joints, faults, and bedding plane variations. This is actually a reasonable hypothesis. Limestone does weather differentially based on its composition. Softer layers erode faster than harder layers, creating the undulating patterns Schoch observed. But here's the problem. If this process created the Sphinx erosion over 4,500 years of desert climate, why don't we see the same advanced weathering on the pyramids and tombs? They're the same age, made from the same limestone, exposed to the same conditions. The weathering should be comparable. It's not. Schoch has argued that the only way to explain the differential weathering between the Sphinx and other Old Kingdom monuments is differential age. The Sphinx is older, significantly older, old enough that it experienced thousands of years of wet climate erosion that the pyramids never experienced. Chapter 7. The Seismic Evidence. In the early 1990s, Schoch collaborated with Thomas Gobekli, a geophysicist, to conduct seismic testing of the Sphinx enclosure. Seismic surveys work by sending sound waves into the ground and measuring how they reflect back. Different materials, solid bedrock versus weathered limestone versus sand, reflect seismic waves differently, allowing geologists to see beneath the surface without digging. What Gobekli's survey revealed was fascinating, and in many ways supported Schoch's weathering analysis. The seismic data showed that the floor of the Sphinx enclosure has weathered to different depths in different locations. The front section, where the pores are located, showed shallow weathering, only about 4 to 5 feet deep into the bedrock, but the rear section, around the hindquarters and tail, showed much deeper weathering, 8 to 10 feet or more into the bedrock. If the Sphinx enclosure was carved all at once, as a single project, why would the weathering depth vary so dramatically? Schoch's interpretation. The rear section is older. It was carved first, during a wetter climate period, and experienced thousands of years of rainfall erosion. The front section was carved later, possibly during a pharaonic restoration or expansion, and therefore shows less weathering. This would suggest the Sphinx wasn't built in a single construction phase, but evolved over millennia, with an original older core that was later modified. The seismic data doesn't prove this interpretation, but it's consistent with it. Mainstream Egyptologists have largely ignored the seismic survey, arguing that variations in bedrock hardness could explain the differential weathering depth without requiring differential age. It's a valid point. Limestone composition isn't uniform, and natural variations could certainly affect erosion rates. But combined with the surface weathering patterns, the climate history, and the lack of similar erosion on confirmed Old Kingdom structures, the seismic data adds another piece to the puzzle. Chapter 8. The Lost Civilization Question. If we accept Schoch's geological dating, if the Sphinx really is 7,000, 9,000, or even 12,000 years old, we're forced to confront an uncomfortable question. Who built it? This is where the theory intersects with much more speculative ideas about lost civilizations, and it's where mainstream academia becomes most resistant. Some researchers, including Graham Hancock and Robert Bauval, have suggested that the Sphinx, and possibly other megalithic structures around the world, were built by an advanced prehistoric civilization that was destroyed by the cataclysmic events at the end of the last ice age. The Younger Dryas period, from approximately 12,800 to 11,600 years ago, was a time of dramatic climate upheaval. Temperatures plunged, ice sheets advanced, sea levels rose and fell dramatically. Some researchers have proposed that a comet impact or airburst triggered these changes. If an advanced civilization existed during the Ice Age, these catastrophic changes could have wiped it out, leaving only scattered monuments as evidence of their existence. This is, to put it mildly, a controversial hypothesis. Mainstream archaeology finds no evidence of such a civilization. No cities, no tools, no clear cultural remains that would indicate the kind of society capable of sophisticated construction. But absence of evidence isn't necessarily evidence of absence. Much of the Ice Age world is now underwater. Sea levels have risen approximately 400 feet since the end of the last glacial maximum. Vast coastal regions where Ice Age humans would have lived are now beneath hundreds of feet of ocean. We've barely explored these submerged landscapes. We don't know what's down there. Could there be ruins of unknown civilizations beneath the Persian Gulf, the Mediterranean, the Atlantic Shelf? It's possible. Some marine archaeologists have found intriguing underwater structures. The Yonaguni Monument off Japan, the megalithic remains near Bimini, submerged structures off the coast of India. None are definitively artificial. All are controversial. But they raise questions. And then there's Gobekli Tepe. Chapter 9. Gobekli Tepe and the Rewriting of Prehistory. In 1994, just a few years after Schoch proposed his water erosion theory, German archaeologist Klaus Schmidt began excavating a site in southeastern Turkey called Gobekli Tepe. What he found was impossible according to the established timeline of human civilization. Gobekli Tepe is a massive complex of megalithic stone circles built from T-shaped limestone pillars weighing up to 20 tons each. The pillars are carved with intricate reliefs of animals: lions, foxes, snakes, birds, scorpions, executed with artistic sophistication. The site was built around 9600 BC. Let that sink in. Gobekli Tepe predates Stonehenge by 6,000 years. It predates the first cities by 6,000 years. It predates pottery, metallurgy, writing, and agriculture. According to everything archaeologists thought they knew, the people who built Gobekli Tepe shouldn't have been capable of such construction. They were supposed to be hunter-gatherers with no permanent settlements, no complex social organization, no monumental architecture. Yet here was a sophisticated temple complex that required hundreds or thousands of workers, coordinated labor, engineering knowledge, and sculptural artistry. Gobekli Tepe forced archaeologists to reconsider the timeline of human development. It proved that our ancestors were capable of far more, far earlier than previously believed. If people in 9600 BC could build Gobekli Tepe in Turkey, is it really impossible that people in 10,000 BC could have carved the Sphinx in Egypt? The comparison isn't perfect. Gobekli Tepe is cruder in execution than the Sphinx, but it demonstrates the principle. We've consistently underestimated what prehistoric humans could achieve, and we've consistently been proven wrong. Chapter 10. What the Egyptians themselves said. There's another intriguing piece of evidence that's often overlooked in this debate. Ancient Egyptian texts themselves. The ancient Egyptians were meticulous record keepers. They carved king lists, documented building projects, and maintained detailed religious texts. We know an enormous amount about their history because they wrote it down. Yet when it comes to the Sphinx, the record is strangely silent. No Old Kingdom text claims credit for building the Sphinx. No 4th dynasty inscription says Khafre built this monument. The earliest textual reference to the Sphinx comes from the New Kingdom, more than 1,000 years after the supposed construction. There are, however, some intriguing references in Egyptian tradition. The inventory stela, which we mentioned earlier, is one of these. Despite being dismissed by most Egyptologists as a later fabrication, it explicitly states that the Sphinx was already in existence when Khufu built the Great Pyramid. It describes how Khufu built a temple beside the Sphinx. The Edfu temple texts, inscribed during the Ptolemaic period, 332 to 30 BC, describe a mythological first time, Zep Tepi, when the gods walked the earth and created the first sacred structures. These texts speak of ancient mounds and temples that predated the pharaonic dynasties. Are these just myths? Probably. Ancient Egyptian religion was deeply mythological, and their historical texts often blended fact with religious symbolism. But it's worth noting that many ancient cultures preserved genuine historical memories wrapped in mythological language. The Epic of Gilgamesh contained references to a great flood that likely reflected real flooding events. The Trojan War was considered myth until Heinrich Schliemann excavated Troy and proved it existed. Is it possible that Egyptian myths about the first time and pre-dynastic monuments preserve a memory of structures built before the pharaohs? It's speculation, but it's not impossible. Chapter 11. The Academic Battlefield. The debate over the Sphinx's age has become one of the most bitter in academic history. Schoch has been ridiculed, dismissed, and professionally marginalized for his theory. Egyptologists have called his work pseudo-archaeology and accused him of promoting fringe theories without proper evidence. He's been denied access to sites for further research. His papers have been rejected by mainstream archaeological journals. He's been excluded from academic conferences, yet he's remained remarkably consistent in his position. I'm not claiming to know who built the Sphinx or why. I'm not proposing lost civilizations or ancient aliens. I'm simply reading the geological evidence as any geologist would read it. And that evidence indicates water erosion requiring thousands of years of rainfall. Other geologists who've examined the Sphinx have largely supported his weathering interpretation. The debate isn't really about whether the erosion looks like water weathering. Most geologists agree it does. The debate is about whether we're willing to accept the implications. Because accepting that the Sphinx is 10,000 or 12,000 years old means accepting that something is fundamentally wrong with our understanding of human history. It means there's a missing chapter, a civilization or culture we don't know about, capabilities we haven't accounted for, and for many archaeologists, that's a bridge too far. The resistance isn't just about this one monument. It's about the entire framework of how we understand human development. Academic fields are built on established chronologies. Careers are built on accepted timelines. Entire theoretical structures rest on the assumption that we have the broad strokes of history correct. If the Sphinx rewrites that timeline, what else needs to be reconsidered? It's not just Egyptian history at stake. It's the global story of civilization. Chapter 12. Where do we stand now? So, more than 30 years after Robert Schoch first examined the Sphinx enclosure, where does the evidence stand? The geological weathering patterns remain. They haven't changed. They haven't been explained away by any alternative theory that fully accounts for all the observations. The climate history of Egypt is well established. The region was significantly wetter before 10,000 BC and has been desert since approximately 5,000 BC. The comparison with other Giza monuments remains stark. The Sphinx shows fundamentally different erosion than structures definitively dated to 2,500 BC. The archaeological evidence for who built the Sphinx and when remains circumstantial at best. And we've learned that prehistoric humans were far more capable than we once thought, as Gobekli Tepe and other sites have proven. Does this prove the Sphinx is 12,000 years old? No. Science doesn't deal in absolute proof. It deals in evidence, probabilities, and the best current explanation. But the geological evidence strongly suggests that either the Sphinx is significantly older than 2,500 BC, or there's a weathering process we fundamentally misunderstand. The honest answer is that we don't know for certain. What we can say with confidence is this: the question deserves serious scientific investigation, not dismissal. The geological evidence deserves serious engagement, not ridicule. And the debate deserves to be conducted with intellectual honesty on all sides. Because ultimately, this isn't about defending academic turf or preserving established timelines. It's about understanding our past as accurately as possible. The Sphinx has stood on the Giza Plateau for thousands of years. Whether that's 4,500 years or 12,000 years remains an open question. But those erosion patterns aren't going anywhere. They're carved into the stone, a permanent record written in the language of geology. And until we can provide a better explanation, one that accounts for all the evidence, not just the convenient parts, the mystery endures. The Great Sphinx has witnessed the rise and fall of empires. It's watched as the climate transformed from green savanna to barren desert. It's seen pharaohs come and go, religions rise and fade, languages appear and vanish, and through it all, it's kept its secrets. Those deep vertical channels carved into the enclosure walls are still there. You can visit Giza today and run your hand along them, feeling the ancient erosion that sparked this entire controversy. The evidence is real. The question is how we interpret it. Science advances not by defending old answers, but by asking better questions. By following evidence even when it leads to uncomfortable places. By being willing to say, we don't know, when the data doesn't fit our models. The Sphinx water erosion theory might be right. It might be wrong. It might be partially correct, pointing toward a more complex history than we currently understand. But the debate itself, the willingness to question, to examine evidence, to consider possibilities that challenge our assumptions, that's how we move closer to truth. The Sphinx isn't going to tell us its secrets easily. After thousands of years of silence, it's not about to start talking now. But the rocks don't lie. The erosion patterns are real. The climate history is established. The comparisons with other monuments are documented. The question isn't whether the evidence exists. The question is whether we're ready to face what it might be telling us.